Hello and welcome to another part of our Azure Developer Ultimate course. Friends, we are starting with question number 51 in this part of our series. You are developing an application to store millions of images in Azure Blob Storage. The images are uploaded to an Azure Blob Storage container named Company Images contained in an Azure Blob Storage account named Company Media. The stored images are uploaded with multiple blob index tags across multiple blobs in the container. You must find all blobs whose tags match a search expression in the container. The search expression must evaluate an index tag named status with a value of final. You need to construct the get method request URI. How should you complete the URI? The parameters given in the options are status equals final, status less than equals final, company media, company images. Now friends, the get method request URI is in front of you and there are 3 blanks that you need to fill. And the correct complete command is now on your screen. Storage account name is company media, which is what needs to be added at the start of the URI. This will be followed by the reference to container name, that is company images. And lastly, the condition would be status equals to final. Let's look at question number 52 of the series. You create and publish a new Azure App Service web app. User authentication and authorization must use Microsoft Entra ID. You need to configure authentication and authorization. What should you do first? Your options are add an identity provider, map an existing custom DNS name, create and configure a new app setting, add a private certificate, create and configure a managed identity. And friends, you should add an identity provider. Mapping an existing custom domain name is only needed if you want your web app to use a custom domain. App settings may be needed later for secrets or environment variables. Certificates are only required for SSL or TLS and for certain secure communication scenarios. And managed identities are for resource to resource authentication within Azure, not for authenticating users of your app. Next question. You create an Azure Cosmos DB for NoSQL database. You plan to use the Azure Cosmos DB.NET SDK version 3 API for NoSQL to upload the following files. There are basically 5 files in the question named as file 1 through file 5 and the sizes are 1 MB through 5 MB. You receive the following error message when uploading the files. 413 entity too large. You need to determine which files you can upload to the Azure Cosmos DB for NoSQL database. Which files can you upload? Your options are different combinations of all the 5 files being mentioned in the table in the question. Now friends, maximum size limit of an item in Azure Cosmos DB is 2 MB. So you should be able to upload file 1 and file 2, making option B as the correct choice. Now folks, let's go through Microsoft documentation and understand some more limits that are applicable to an item in Azure Cosmos DB. So friends, let's go through this table which applies to per item limits. Now the maximum size of an item can be 2 MB, which is what our question was based on. The maximum length of partition key value can be 2048 bytes. Maximum length of ID value can be 1023 bytes. Allowed character for ID value. Server side, all Unicode characters except for backward and forward slash are allowed. Now there is a warning. I would highly recommend you to go through that warning as well. Now there are some resources mentioned for which there is no practical limit. And then the maximum level of nesting for embedded objects or arrays set to 128. Make sure you have that into consideration while you get such type of questions. Then there is a maximum TTL value defined and some more maximum or minimum applicable values are defined. Now, the key thing to note here is large document sizes of up to 16 MB are supported with Azure Cosmos DB for MongoDB only. So friends, in our question, we were talking about NoSQL API. That's the reason why we were saying that the maximum size of an item is 2 MB, but if the question is talking about MongoDB, then that value changes to 16 MB. Make sure to keep that in mind. Question number 54 of the series. You are developing an application to store business critical data in Azure Blob Storage. The application must meet the following requirements. Data must not be modified or deleted for a user specified interval. Data must be protected from overwrites and deletes. Data must be written once and allowed to be read many times. You need to protect the data in the Azure Blob Storage account. Which two actions should you perform? Your options are configure a time-based retention policy for the storage account, create an account shared access signature, enable the blob change feed for the storage account, enable version level immutability support for the storage account, enable point in time restore for containers in the storage account, create a service shared access signature. Now folks, the first action would be to configure a time-based retention policy. With a time-based retention policy, users can set policies to store data for a specified interval. When a time-based retention policy is set, objects can be created and read, but not modified or deleted. After the retention period has expired, objects can be deleted, but not overwritten. Now you should also enable version level immutability support for the storage account. This lets you apply immutability at the blob version scope in addition to container scope to protect against overwrites and deletes. Next question. You are developing a solution to store documents in Azure Blob Storage. Customers upload documents to multiple containers. Documents consist of PDF, CSV, Microsoft Office format, and plain text files. The solution must process millions of documents across hundreds of containers. The solution must meet the following requirements. Documents must be categorized by a customer identifier as they are uploaded to the storage account. Allow filtering by the customer identifier. Allow searching for information contained within a document. Minimize costs. You create and configure a standard general purpose V2 storage account to support the solution. You need to implement the solution. What should you implement? Friends, the first part of the question is talking about search and filter by customer identifier. Your options are Azure Cognitive Search, Azure Blob Index Tags, Azure Blob Inventory Policy, Azure Blob Metadata. Folks, we want to tag each document with a customer identifier and then be able to filter or search on that. So you should make use of blob index tags. They store key value pairs that are automatically indexed by Azure Storage, enabling fast filtering and searching across containers. Now, blob metadata allows you to store key value pairs, but metadata is not indexed for efficient search. Filtering millions of documents would be slow and not a scalable solution. Friends, the next part of the question is talking about search information inside documents. And again, you have all those four options. Now, goal here is to extract and search the content of PDF, CSV, Office files, text files, and you should use Azure Cognitive Search for that, as it provides full text indexing, OCR, and natural language search on document content. It integrates with blob storage via indexers. Remaining options only work on metadata or system properties and not document content. Question number 56 of the series. You are developing an Azure solution to collect point of sale device data from 2000 stores located throughout the world. A single device can produce 2 megabytes of data every 24 hours. Each store location has 1 to 5 devices that send data. You must store the device data in Azure Blob Storage. Device data must be correlated based on a device identifier. Additional stores are expected to open in the future. You need to implement a solution to receive the device data. The solution you choose is provision an Azure event grid, configure the machine identifier as the partition key, and enable capture. Does the solution meet the goal? You need to tell whether this is right or wrong. And friends, this is an incorrect solution. The correct approach here would typically be Azure Event Hubs with capture, partition by device ID, and store in blob storage. Friends, if you're liking the content, do not forget to hit the like button and subscribe the channel. Let's move on to question number 57 of the series. You have an existing Azure storage account that stores large volumes of data across multiple containers. You need to copy all data from the existing storage account to a new storage account. The copy process must meet the following requirements: automate data movement, minimize user input required to perform the operation, ensure that the data movement process is recoverable. What should you use? Your options are AZ copy, Azure Storage Explorer, Azure Portal, .NET Storage Client Library. Folks, the obvious correct answer here is AZ copy. It is a command line tool built for fast automated data transfer between storage accounts and supports resumable uploads and copies and retry logic. It requires minimal user input once the command is configured. Next question. An organization deploys Azure Cosmos DB. You need to ensure that the index is updated as items are created, updated, or deleted. What should you do? Your options are set the indexing mode to lazy, set the value of the automatic property of the indexing policy to false, set the value of the enable scan inquiry option to true, set the indexing mode to consistent. Now friends, setting the indexing mode to lazy updates the index asynchronously, not immediately. Index is eventually consistent but not updated right away. Now setting the automatic property to false disables automatic indexing means you would have to manually specify index updates. Setting the enable scan in query value to true allows queries to scan data without indexes but does not update the index. Setting index mode to consistent ensures the index is updated synchronously with create, update, delete operations. This guarantees queries always see up-to-date index data. Now friends, there is a link on your screen. Go through the link to understand more about different type of indexing policies in Azure Cosmos DB. Question number 59 of the series. You are developing a solution that uses the Azure Storage Client Library for .NET. You have the following code. Now line numbers are included for reference only. Folks, take some time, go through this snippet and then look at the next part of the question, where we are talking about different statements and you need to tell whether those statements are right or wrong. Folks, the first statement is the code creates an infinite lease. This is a correct statement. Now line 5, acquire lease as sync null requests an infinite lease because the lease duration is null. Now this second statement is the code at line 6 always creates a new blob. This is an incorrect statement. Get block blob reference where src.name is specified just creates a reference to the blob in the same container. Now the third statement is the finally block releases the lease. This is a correct statement. In the finally block, if lease state is not equals to available, it calls break lease sync, which breaks the lease. Next question. You develop an Azure App Service web app and deploy to a production environment. You enable application insights for the web app. The web app is throwing multiple exceptions in the environment. You need to examine the state of the source code and variables when the exceptions are thrown. Which application insights feature should you configure? Your options are Smart Detection, Profiler, Snapshot Debugger, Standard Test. Now folks, Snapshot Debugger captures snapshots of the application's state at the time exceptions are thrown. This includes variables, call stack, and source code line. Smart detection automatically detects anomalies and failures. Profiler captures performance traces, and a standard test is used for availability testing. Next question, friends. You are developing a web application that uses Azure Cache for Redis. You anticipate that the cache will frequently fill and that you will need to evict keys. You must configure Azure Cache for Redis based on the following predicted usage pattern. A small subset of elements will be accessed much more often than the rest. You need to configure the Azure Cache for Redis to optimize performance for the predicted usage pattern. Which two eviction policies will achieve the goal? Your options are no eviction, all keys LRU, volatile LRU, all keys random, volatile TTL, volatile random. Now folks, all keys LRU evicts the least recently used item across all keys, making it perfect for hot or cold usage patterns. Volatile LRU evicts least recently used items only among keys with a TTL set, making it good if TTLs are used. Now folks, let's understand all the eviction policies in more detail. So friends, on your screen is an article on Redis website which is talking about the different eviction policies. So the first one is no eviction. Keys are not evicted, but the server will return an error when you try to execute commands that cache new data. If your database uses replication, then this condition only applies to the primary database. Note that commands that only read existing data will still work as normal. So friends, the first policy is no eviction, which obviously is not going to evict any keys and you are going to start seeing errors. All keys LRU is the one which we already discussed in the question, which evicts the least recently used keys. Now all keys LFU evicts the least frequently used keys. All keys random, evict keys at random. Friends, the names are self-explanatory. You just need to understand the full form of LRU, LFU, TTL to understand what that key is talking about. Now, volatile LRU evicts the least recently used keys that have the expire field set to true. Volatile LFU evict the least frequently used keys that have the expire field set to true. Volatile random, similar to all keys random, is going to evict keys at random only if they have the expire field set to true. Volatile TTL is going to evict keys with the expire field set to true that have the shortest remaining time to live value. So friends, the key difference between all keys and volatile is all keys, as the name indicates, is going to look at all the keys, whereas the volatile policies are going to look at the keys which have the expired field set to true. Then LRU and LFU are same. Let's now look at next question in the series. You are developing an Azure App Service hosted ASP.NET Core Web App to deliver video on demand streaming media. You enable an Azure Content Delivery Network standard for the web endpoint. Customer videos are downloaded from the web app by using the following example URL. There is a URL in front of you. All media content must expire from the cache after 1 hour. Customer videos with varying quality must be delivered to the closest regional point of presence node. You need to configure Azure CDN caching rules. Which option should you use? The first part of the question is talking about cache behavior. And your options are bypass cache, override, set if missing. Friends, cache behavior should be override as it forces a specific cache duration regardless of origin headers. This is best choice here since we want a strict 1 hour cache expiration. Now the next part of the question is talking about cache expiration duration, and your options are 1 second, 1 minute, 1 hour or 1 day. Cache expiration duration will be 1 hour as it is clearly mentioned in the question as well. The content must expire from the cache after 1 hour. This is the statement I'm talking about. Now the next part of the question is talking about query string caching behavior. Your options are ignore query strings, bypass caching for query strings, cache every unique URL. Here you will choose cache every unique URL. It ensures each variation of quality equals to X is cached separately. So folks, that's all for this part of the series. If you have not watched previous parts of the series yet, then link to the playlist is available in the description section of the video. Make sure to subscribe the channel and turn on the notifications so you are notified when the further parts in the series are released.